All right, sample problem. Incline plane. So we've learned pulleys. We've learned just forces sitting on a flat surface with forces acting on them that may be in the x direction, maybe in the y, or they may go off at some angle. And then now we're going to learn about incline planes. Okay. Now this is a very, very, very common problem. Okay, so you need to make sure that you know how to do this one. All right, so a block with a mass of 2.5 kilograms sits on a frictionless ramp with an angle of inclination of 35 degrees. How fast does the block accelerate down the ramp? All right, so we're going to start with our picture that we always do. And there is my inclined plane. There is my block. Okay? So, if I'm going to draw a free body diagram, what does that look like?
Well, the gravity and are going straight up and down from that, or is it going to the side of gravity?
Gravity, normal force, angle, and friction.
Okay.
And gravity is basically.
So let's do it this way first. You guys are telling me gravity. I will agree with that. There is force of gravity. And then there's also what? Normal force. Is there any other force acting on this? In this problem, it says it's frictionless.
No.
No. All right.
But the gravity is basically pulling it down. Not
The gravity is pulling it downward, down the ramp. That's right.
Somehow it's staying on the ramp.
But somehow it's staying on the ramp. Okay, so here's how this looks. First of all, we know that the normal force is always what?
Perpendicular.
Perpendicular to the surface. Okay? And then the question is gravity also perpendicular to the surface, or is gravity straight down as we would know it? So there's gravity. Okay? So the question is, how does this inclined plane start going down, or how does this block go down the inclined plane? Which force is causing it to go down that inclined plane? Okay, the gravity is causing it to go down the inclined plane. Okay, so here's how we've got to work this problem. All right, we've worked everything to where we said there's our coordinate system. I don't want to do that on this problem. And when we first started talking about coordinate systems, does anybody remember what I said?
Pick it.
You are in charge of that. You can pick whatever coordinate system you want to make your life easier. And I'm going to pick a coordinate system. And one of the ways that I want this system to go, it would be very nice to me if one of my axes was parallel to the inclined plane, going down. So I'm going to say X is now like that. And I'm going to say that's positive. Down the inclined plane is positive. I know it's going to the left, but I'm saying down the plane is positive. That's me. I always pick it that way. That way I don't have to think about it. That's me. Some people don't do that. Okay. The reason that I pick down the inclined plane is because that's the most natural way that this block is going to move. This block is going to move down the inclined plane. Unless there's another force acting on it, it won't go up, right? That's a whole nother law that we'll get into later. Okay, what can you guys tell me about the two axes X and Y? Describe them in relation to each other. An X-axis and a Y-axis that you know so far. They're what? They're perpendicular. So if I'm going to have an X and a Y axis, they need to be perpendicular. So that means my y-axis is 90 degrees, and it goes up like that. So what I've done, and what I'm going to do on every incline plane problem that I ever work, I'm going to rotate my axes by how much?
The degree.
Yeah. The degree that the angle of inclination. And that's not really that important that you know that, but that is what I'm doing. Okay. All right, so just to kind of throw this out there, how much did I rotate this downward? 35 degrees. Okay, and from this little piece right here to this piece right here is how much? 90 degrees. And so then that means that this little piece right here, if I were to rotate it in parallel with this y-axis, is how much? So these are, how far is it from here to here? 90. And it's 35 degrees from there to there. So this is 35 degrees also, just so that you know that. Okay, so now look at our free body diagram. The normal force is in which direction? Positive in the y. That's perfect. I love that. But gravity is what? Negative in both. So whenever I have a vector that's in both, what do I always do? I have to resolve it. So here it is. There's my y component that I just drew. Can y'all see those little dots? Here's my y component. And here's my x component. What is this angle right here? 35 degrees. We just proved that right here. Okay, so this is 35 degrees. All right, so now here's where you get to be careful. I'm going to call this force of gravity. Force of gravity in the x direction is m times g, and I'm talking about this little piece right here. Where is that in relation to my angle, 35 degrees? Here's my angle.
Sine, cosine.
Yeah, is it opposite or adjacent? It's opposite, and opposite goes with what? Sine. So this is actually sine 35 degrees. And FG in the y direction is mg cosine 35 degrees. So this is m is 2.5, g is 10, sine 35 is something that I'll have to punch in my calculator. This is 2.5 times 10. Cos 35 is something that I'll have to punch in my calculator. I get 14.34 for x and 20.48 for y. Okay, now I've drawn a free body diagram. I've resolved my vectors. Now what do I do? What's the next step in every process that I've taught you so far? Add up sum my forces in the x, sum my forces in the y. So sum of forces in the x direction. I have the force of gravity in the x direction. In which direction is it going? Up or down the inclined plane?
Down.
Down, and I've said down is what? Positive. Is there any other force acting on it? No. So it equals m times what? A. Mass times acceleration. And I predict that the acceleration is down the inclined plane, which is what? Positive for us. Sum of forces in the y is equal to the normal, which is positive, and what else? Force of gravity in the y direction. Is it moving in the y direction?
No.
It is not. If it were, think about this for a second.
It wouldn't be.
The surface of my inclined plane is my x-axis, right?
Yes.
So is it always sitting on the x-axis?
Yes.
So is it moving in the y direction?
No.
No.
No. Okay, does that make sense?
Yes.
So that's a 0. So normal is equal to the force of gravity in the y direction, which would be important if we had friction. Okay, and FGX, which is
Source of gravity.
14.34, is equal to M, which is 2.5, times A. Normal is equal to 20.48. It's positive. 14.34 divided by 2.5 is 5.74, and that's equal to A. So A is 5.74 meters per second. And it's going which way?
Positive.
Which is
Down the slope.
down the inclined plane.
Isn't that meters per second squared?
Job. All right. That's going to take a little bit of practice. You're going to get some practice with it. Okay, the one thing I need to talk to you guys about the homework I'm going to pass out in just a second, the force of a spring, and I talked about this once before, but I'm just going to bring it up again. A spring is, the force of it is based on how much you stretch that spring from an equilibrium position. So the force of a spring is equal to K, which is a spring constant, times X, which is how far you stretch or compress it. Now, here's the story. If I pull X out,
It's positive.
X is positive. Which way is the force? It's pulling the opposite direction, right? So the actual formula that you will see is negative K times X. But listen to me. Just find out what K times X is. Figure out which way the spring is pulling, and you decide if that's positive or negative. Okay? So you're finding the magnitude, and then you're determining whether it's positive or negative. Okay? That's yours.